Very good evening, my dear GW soldiers. Very good evening, very good evening, very good evening. First of all, kindly let me know, am I audible? Am I audible, everyone? Each and everyone, audio video is clear? Everyone. Let me know fast. Audio video is clear? Yes, bachcho. Very good evening, very good evening, very good evening. First of all, kindly let me know. Yes, Sima, very good evening, beta. Very good evening. God bless. Audio video is clear? Each and everyone. Any other issue? Getting na? Okay, very good. Very good. So, my dear student, once again, very good evening, my dear GW soldiers. Today, we are going to start property of decomposition part 2. In this, we will discuss lossless joint decomposition and dependency preserving decomposition. And before we start this, I want to discuss first of all what we done till now. We discuss each and everything. We discuss RDBMS concept, my dear. FD concept and its type. FD concept and its type. After that, we discuss attribute closure. Then we discuss keys concept, in which we discuss super key, candidate key, finding multiple candidate key, and membership set. Membership set, my dear. Yes, very good evening. Suryavanshi, Prashant. Prashant, very good evening, beta. God bless. Then we discuss equality between two FD set. After that, we discuss finding number of super keys, finding number of super keys and candidate keys also. Then we discuss FD closure, closure of FD set and redundant FD, या minimal cover या canonical cover, minimal cover, and properties of decomposition. Properties of decomposition, in which lossless join and dependency preserving. There are two parts. Lossless join and dependency preserving, my dear student. And first of all, we are discussing lossless join. Whatever the meaning of lossless join decomposition, I told if we trying to join, if we are getting the exact table, means not getting any spurious tuple, then we can say it is a lossless join. But if we are getting spurious tuple, then we can say it is a lossy join, my dear. It is a lossy join. Now, my dear student, I told another approach also. What is the another approach? Let R be the relational schema is decomposed into sub-relation R1 and R2. So, if R1 join R2 is lossless, if and only if, first point, R1 union R2, you are getting exact R. Second, common attribute of R1 and R2, either a super key of R1 or super key of R2. Super key of R1 or super key of R2, my dear. super key of R2, my. This is the meaning of lossless join. This is the meaning of lossless join, my dear. This is the meaning of lossless join. And when it will be lossy? When it will be lossy, my dear student? Let me know fast. When it will be lossy? Please tell me fast. When it will be lossy? When it will be lossy? R1. What I am saying? When it will be lossy? When you trying to join R1 and R2 is lossy join if and only if. What is the condition? First, when common attribute. Yeah, first condition you can say when you trying to join R1 union R2, you are not getting original relation R. Second, if common attribute of R1 and R2, common attribute of R1 and R2, neither a super key of R1, second, nor super key of R2, then we can say it is lossy. What I am telling, when you take the common attribute, sir, neither you are getting R1 and nor you are getting R2, nor you are getting R2, neither R1 super key nor R2 super, then you can say lossy. Third point, if a relation decompose in such a manner like R1 AB and R2, then directly without open your eyes, directly you can say lossy join, because no common attribute, because no common attribute, my dear. In that case, it is lossy. In that case it is lossy, my dear. In that case it is lossy join. Crystal clear, everyone? Each and everyone, let me know. Crystal clear, please. Crystal clear, everyone, everyone, let me know fast. Clear? Very good. Now, like here you can see which FD is satisfying, which FD is satisfying, my dear student, which FD is satisfying. Here you can see, can A tends to B is satisfying? In this, can A tends to be satisfying? Yes, 1 2 3 7 7 9. Clear? 1 2 3 7 7 9. A tends to B is satisfying. A tends to B is satisfying. Now, what is the common attribute? What is the common attribute here? B. When we take the closure of B, when we take the closure of B, when we take the closure of B, we are getting only B. Mean to say, not a super key of R1 and not super key of R2. What we can say? Lossy. Yesterday we proved this, it is a lossy. Yes or no? Yesterday we proved it is a lossy, my dear. Clear? Clear? Each and everyone crystal clear? Second, here R1 AB and R2 AC. And what is the FD? I am telling A determine B. Okay. What is the common attribute here? Here common attribute is A, my dear. When we take the closure of A, what we are getting? AB super key of R1. Super key of R1. So what we can say will be lossless. Will be lossless join. Okay, Advin Suryavanshi, please bacha try to understand, and those student having first class today, I am again start lossless join. Bacha, what is the meaning of lossless join and how we check? How we check lossless join? There are two methods for checking your data is lossless or not. Lossless join. First one is chase test that I will start today. Don't worry about that. Second one is binary or successive approach. Binary method you can say, या successive approach. Okay, my dear. So these are the two methods. First of all, chase method. Second one is binary approach. So first of all, I'm discussing binary. Binary means what? If a relation is decomposed into two sub-relation, yeah, you are making two combination one time. That is the meaning. Now listen, everyone. If a relation R is decomposed into sub-relation R1 and R2, R1 and R2. So R1 join R2 is lossless if and only if when you take the union, you are getting the exact relation R, and if common attribute, either a super key of R1 or super key of R2, Advin, either a super key of R1 or super key of R2, then it will be lossless, my dear. Mean to say, whatever common attribute you are getting, when you take the closure, then you are getting either R1 completely or R2 completely in a simple manner. And when it will be lossy, when you take the union, you are not getting the exact relation R or common attribute, neither a super key of R1 nor a super key of R2, then it will be lossy. Or nothing is common, then it will be lossy. Like here, I have taken example number 1. Here R1 AB and R2 BC. And this FD is given A tends to B. What is the common attribute? B. When you take the closure of B, then what is happening, my dear? You are not getting anything. So from the closure of B, you are getting only B. Mean to say, neither getting AB, neither getting nor getting BC. Mean to say, not a super key of R1, not a super key of R2. So you can say it is a lossy join. Clear? Second question, here you can see what is the common attribute. A is common. So when you take the closure of A, what is the meaning of closure? Advin, what is the meaning of closure? Whatever attribute you can determine directly or indirectly with the help of attribute A, that is the meaning of closure of A. Okay, so when you take the closure of A, you are getting AB. That means super key of R1. Mean to say, super key of R1 mean to say it is lossless, my dear. It is lossless. Still clear, everyone? Still clear? So what I told here, when you take the closure, either you are getting R1 completely or R2 completely, then it will be lossless. Or tabular method I told yesterday, with the help of data, when you join, you are getting exact relation tuples, then it will be lossless. Now solve this one, beta. Solve this one. Pin clear hai, beta? Each and everyone clear? Tell me fast. Each and everyone, tell me fast. Everyone. Let me know. Yadeep, Pin. Yes, let me know fast. Very good. Why? What is the reason for this? Please check it, my dear. Check it. Here you can see R1 is what and R2 is what? F. When you take union, when you take union, here Venn diagram is not working. Ima, here Venn diagram is not working. That is only applicable for finding the number of super. Here, what is the role of Venn diagram? How you solve with the help of Venn diagram? Please let me know. So here, when you take the union, what is happening, my dear? You are getting A, B, F, A, B, C, D, E, F. You are getting all attribute. Are getting all attribute A, B, C, D, E, F, G, my dear. Clear? Now, what is the common attribute here? Step number one, you check it. First of all, there is a no need of step number one. You can calculate in your mind also. You can calculate in your mind also. Yes, A, B, C, D, E, F, G, we are getting all attribute. Okay. Now, what is the common attribute here? What is the common attribute here? D. When we take the closure of D, then what happen? D, E, F, G. D, E, F, G, my dear. D, E, F, G. That is what? Super key of R2. Super key of R2, my dear. So what we can say? It is lossless. Is lossless join. When you decompose, then you are getting each and every attribute R, A, B, C, F, G, and it is lossless join, my dear. It is lossless join. Crystal clear, everyone? Crystal clear? Each and everyone crystal clear? Let me know fast. Everyone, everyone, everyone. Now, same question, same question you have to solve with the help of chase method, chase test. Okay. So I know chase test you don't know right now. Chase test. What beta? Chase test. This is given in one book. First of all, you let me know everyone. Am I tell the chase method? Yeah, you will solve this question by this approach. Can I explain chase method also? Let me know fast. If yes, then write down heart chat box. Please everyone. Write down heart in chat box. Case test if you want. Please, please, please. Please everyone. Everyone. Now, thank you. Now, listen everyone. Case test. It's a very simple and I'm not any commenting on anyone, but I am explaining all things which I read from the Ulman, and I not teach in the crash course this chase test due to shortage of time, but this time I am explaining chase test. Okay. So what is the meaning of chase test? First of all, it is a matrix approach. Matrix method. What we do, my dear, what we do, please try to understand. Here we make a column and row. Okay. Here we make a column and rows, my dear. Column and row. Here, please try to understand what I am telling. What I am telling. Here I make a column and rows. Here column is represent attribute. Column is represent attribute and rows represent the sub relation. represent the sub-relations. Rows represent the sub-relations and column represent the attribute. What I am telling, put your pen down, everyone. Now I am telling each and everything from the basic, don't worry. Okay, change method. First of all, here we create a matrix. You can say create matrix, you can say table, you can say table in which column represent attribute, and row या represent tuple represent sub relation, okay. Then what we do, then fill the entries, the cells with corresponding, please keep patience for this, you will get it definitely, corresponding sub relations या corresponding attribute of corresponding sub relation. What is the meaning of this line? I will tell you. Corresponding sub relations, what is the meaning? Acha, tell me how many of you know the chess test? How many of you? If yes, yeah, write down no, my dear. Yes, yeah, write down no. How many of you? Please. Now fill the entries with any variable, you say any variable, either a, alpha, whatever. Okay, don't worry, I am explaining each and everything. Keep patience. I am telling each and everything from the basic, and this is from the authentic source, that is Ullman book. Ullman book mentioned because course not mention the chase method, है ना, chase test. Ullman mentioned the chase test, है ना, mainly Ullman completely describe this chase test. I am explaining, but I have prefer this one. Okay, you can prefer chase test also. This is also giving the correct result. Don't worry about. Okay, so what I am telling, chase test. First of all, step number one, you can say we create a table. Yeah, we create a matrix. We create a matrix in which row is represent the relations, whatever sub relations, whatever sub relation that is represented with the help of rows, and column represent the attributes. Column represent the attribute like A, B, F, G. This represent by the column. This step is clear. Then we fill any entries, any, then fill the entries, any variable, assume A. I am filling A. Whatever attribute, whatever is given, na, then fill A. Okay. Now, second step, fill the entries using the FDs. Using the FDs. And how they fill? If in X tends to Y, FD, if in X tends to Y, FD, X having two values, X having two same values, you can say, then fill the Y values. Now there are various cases. Now here there are two cases. Y not have the values and Y have one value. I know you are not getting. I know you are not getting, but I will tell you. For example, bacha, if we are getting in X column, please try to understand what I am saying. Please try to understand what I am saying. If there is a one FD, X tends to Y. Now here let us assume there are two. Here I am explaining na. There are fill A. There are two entries. There are two. Okay. Now here, if we have A, there are possibility, this one possibility, or this is the possibility. What? is the possibility. Now please try to understand what I am saying. What I am saying, first of all, we fill the entries. What entry we fill? You can fill any value, any variable like a, yeah, alpha, yeah, beta, yeah, any value, any variable you pick. In the Ullman book, it pick a. Okay, fill all the corresponding relation a. Then whatever is given in the initial. Now fill the entries with the help of given FD set. And how the given FD set? If x tends to y, FD is given. If x tends to y, FD given, then if x has two values, same values, x has two same values, then why there are two cases. Why there are two cases? Either you will get y with one entry, you will get y with one entry, or you will get y with zero entry. Okay, but x value have repeat. X value repeat. Yeah, two x values are there. You can say if two x values, two x same values are there. I will explain. Don't worry. Two x same value. Same value of x are there. You can say two same value of x. Same value of x are there. So my dear student, what you fill here, please let me know what you fill here in a y. In a y, what you fill? Because you know FD means what? X tends to y means what? T1 dot x equal to T2 dot x. Then T1 dot y equal to T2 dot y must be. Please try to understand. Ana, in some places you will find the wrong. In some places you will find the wrong. I am not criticizing, I am not pointing anyone. My intention is very clear. Please try to understand the correct approach. Okay. Now listen, bacha. What I am telling. FD definition is what? FD definition is what, beta? X tends to y means what? If T1 dot x equal to T2 dot x, then T1 dot y equal to T2 dot y must be. For example, ki if my roll number repeat, then my result will be display. Then my result will be display, my dear. Okay. So here you can see, beta, here there are two value of x that is same. Here we are getting a. What we are getting here also? Let me know, please. Let me know, please. What we are getting? Let me know, please. Tell me fast. Tell me fast. What we are getting? Tell me fast. Bacho, you are thinking it is a tough, it is a easiest approach. Jadi first start this one, beta. Now, here you are getting, okay. And sir, if here nothing is there, then what you fill? Then what you fill? You fill any value, same, any value. Getting my point? Bacho, but it is not mentioned most of the. Yes, I'm not taking any name, not commenting anyone. My intention is very clear. Please learn the good. That's all. Okay. Now listen what I'm telling. Ki bachcho, if x value, one x value is given in RHS, then fill the same value because T1 dot x equal to T2 dot x. Whenever my roll number repeat, my name will be displayed. Okay. So T1 dot x equal to T2 dot x, then T1 dot y equal to T2 dot y must be. But if RHS, we don't have any value, then what we do? We fill one any value, that is B1. B1. A, B1, B1, B1. But that must be same, satisfying the FD definition. Second case. है ना? Or there are two cases for this one. How we fill the entries in x tends to y? There are two cases. If x having two same values, then if x having two same values, just wait, Sham, just wait. If x having two same values, then there are two possibility. Ki y having only one value. If y having only one value, then fill A. If y not having any value, then what you do? Instead of filling A, you fill B1. Okay, that is explained, directly mentioned in the Ullman book also. Now, in x tends to y, x in x, no two values are same. No two values are same. Then don't consider that FD. Don't consider that FD. Mean to say here any FD is given x tends to y, any FD is given x tends to y, but here only one value is present. Here only one value is present, then you can't do anything. No two same values, no two same values, or same values is nothing, you write only A. Okay, I know you are not getting right now, but little keep patience for 5 minutes only. 5 minutes, definitely you will get each and everything. Definitely you get each and everything. This point is crystal clear, bacha? This point is crystal clear. Now, what is happening if we find a tuple या row with all a variable entries, then it is lossless. Then it is lossless. Change algo stop, change test stop if we find all a entries, Wallah tuple, hold, no updation in the table. Are you getting my point? Again, I am telling bachcho what we do. Please keep patience. Here I have written, देखो बच्चों, here I mention Wallah, Wallah, huh? Gate Wallah. But spelling here double L is there. Okay. Now listen, bachcho, what I am telling. Please try to understand. I make it simple. Don't worry about that. I written each and every concept due to shortage of time. है ना? I forgot to give the types. Otherwise, you will get in written form also. And it is I have mentioned in my words with the help of Ulman book. Okay. Now listen. What I am telling. First of all, we create a matrix in which column represent a attribute and row represent a sub relations. Okay, and fill the entries any variable. Here I am using variable a. Here I am using variable a. Any variable I fill a. Where I fill a, what is the sub relation corresponding attributes. Okay, then I try to fill the entries with the help of FDs, with the help of given FDs, with the help of given FDs. X tends to y given FDs. Now there are 2 points. In a x tends to y, FD is given, but if x value 2x having the same values, then we fill y entries. If 2x having the same values, then we fill the y entries. Now there are two possibilities. Either you will get one y value or you will not getting any y value. So, but FD is given x tends to y. When you will get one y value means here you are getting a to a. So here this FD is satisfying. This FD according to the given schema is satisfying. So what we do, we will write a to a, because let's suppose roll number 11. Roll number 11, that is the result of Sham. So whenever in future roll number 11 repeat, then which candidate result will be display? Sham result will be display. Sham will be display. Sham will be display. Sham will be. Getting my point? So whenever I insert 11, Sham will be displayed. Okay. Second case, if y not having any value, if y not having any value, you are getting 2x values, but y not having any value, then what we do? Then what we do, my dear? Then what we do? What we do? That any value that is same. But this must be satisfied. Okay. Third step. Yeah, sir, if in x tends to y, no two values are same. No two x values are same. No two x value, no two x values are same. For example, you are getting only one value of x. Like you are getting only 1a, not getting 2a. So you can't apply this definition, na? Because this applied the definition ki whenever my roll number repeat, whenever my roll number repeat, then my result will be displayed. Whenever roll number 11 repeat, then Sham result will be displayed. It repeat at support 2 times, then result of Sham will be displayed. If repeat 4 times, then result of Sham will be displayed, my dear. Clear, bacha? So if roll number not repeat, then you can't fill. You know the FD concept. Okay. So then don't consider that FD. Now we repeat this process. If we find any tuple with all A entries, any tuple in which all A entries, either this one or this one or this one, any tuple with all A entries, then what we can say, it is lossless. It is lossless. Or when the chase test stop, if we getting, देखो बच्चों, it may be lossy ना, it may be lossy. So when you have to stop chase test, if we find all A entries, वाला tuple, any tuple you are getting in which all entries with A are filled, or you try to fill the entries, but in table there is a no updation. In table there is a no updation, then it will be lossless. Clear? Are you getting my point? What I'm telling, if you are getting all entries, all with A entries, that it will be lossless, or you are not getting any change, then it will be lossy. Sorry, I told lossless. If no changes, either you are getting, I told only this point. If we getting all A entries, then it means lossless. Otherwise lossy. And what you do check for a lossy, you are updating a table with the FDs but no updation, then you stop, because you not execute till 9 to 11, 9 to 12, 13 gate examination. No, my dear. Okay, now here I am explaining this chase test. Okay, bacha, now here I am explaining the chase test. Please put your pen down, everyone. It's my humble request to all of you. How many attributes? 7. 1, 3, 4, 5, 6 and 7, and there are 2 relations. Okay, bacha, what is the relation number 1? R1 and R2. R1 is what? A, B, C, and R2 is what? F. Here I am getting A, E, F, G. My dear, I will take one big question. Don't fear your Vijay sir. First of all, write down in chat box if you are enjoying or not. Now, what I do, my dear, I told step number 1, what? Column represent attribute and tuple represent the sub-relations. I mention here. Now, what I mention, then fill the entry variable A, with corresponding attribute, of corresponding sub-relations. Mean to say, like here, A, B, C, D. What I do, I will write A, B, C. And here D, E, F, G. What I write? D, E, F, I write A. Clear, everybody? Each and everyone crystal clear? This is the step number 1. Ki fill the variable A in the cell with the corresponding attribute of corresponding sub-relation. What is the meaning of corresponding attribute of corresponding sub-relation? Means here A, B, C, D. I will write A. Here D, E, F, G. Enjoy, my dear. Why you fear? D, E, F, G. Write down A. Crystal clear till now? Acknowledge, please. Then, my dear, I will take each and every FD and check. Am I able to fill or not? I will take each and every FD. AB tends to D, D tends to E, E tends to FG. E tends to FG, my dear. E tends to FG. Beta Shima, acknowledge fast, bacha. Each and everyone acknowledge fast. Just a minute. Yes. Now listen, bacho. Here we done the step number 1. Now check AB tends to CD. AB tends to CD. Beta. In AB tends to CD, FD number AB tends to CD. Can we have two AB value? Can we have two AB tuple with same value? क्या AB में दो वैल्यू है? Everyone let me know. SQL एंड रिलेशनल अलजेब्रा कराओगे क्या? हाँ पक्का कराएंगे, पक्का कराएंगे. जरा धमका रहे हो बेटा, हाँ जीवन. और SQL और रिलेशनल अलजेब्रा कराओगे पक्का? यस ऑफ कोर्स बेटा, डोंट टेक अदरवाइज आई विल टेक इट, है ना. फर्स्ट ऑफ ऑल एंजॉय दिस. Okay, Jivan. Now, please tell me, बच्चों reply fast. In AB tends to CD, what I told beta, what I told कि if no two x values, no two x values in x tends to y, no two x value are same, then don't consider that FD. Don't consider that FD. For example, AB tends to CD, AB don't having two values, AB don't having two values, then you can apply this point. You can't apply this point. So AB tends to CD, you can't apply. Can we apply D tends to E? Can we apply D tends to E? Can we apply D tends to E? Now you can see, my dear, my dear, my dear, D tends to E. Here D value are same. Here D value are same. Then what we do? Are getting E. Because here you are getting A. Here you also A, my D. Chamka everyone. D tends to fill, my dear. Let me know fast. Let me know fast. Getting? What I told कि if any FD in which X has the two same values, then what happen if one time A is mentioned? Then according to this, if roll number 11 Sham, again roll number 11, Sham result will be display, my dear. Sham result will be display. Crystal clear everyone? Each and everyone crystal clear? Sham. Let me know fast. Now, E tends to FG. E tends to tell me fast. E tends to FG. So my dear, here you are getting two E values. Two E values are same. In this you are getting AA. What you insert here? AA. My dear student. Here you can see. Here you can see, bacha. Here you can see. You are getting all values with A. Then what we declare? Lossless join. What we declare? Lossless join. Chamka. Very good. A wala entries in gate wala. Getting na? That's why it is lossless. Clear everyone? Sima, Sham, Jadip, each and everyone crystal clear? Let me know fast. Now, solve this question by the chase test. Acha, first of all, solve by another approach. Solve this one, please solve this one. Do it fast. Solve this one, beta. Solve this one. Everyone solve this one. Each and everyone solve this one. Solve this one. So you can solve by any approach. First of all, I am solving with first approach. What is the first approach? R1 A B C E union R2 D E F G. What we are getting? A B C D E F G. We are getting original R. We are getting original R, my dear. We are getting original R. We are getting original R. Now A B C E intersection D E F G. What is the common attribute? E. So when you take the closure of E, what we are getting? Only E. not super key of R1 and not R2. So what we can say, my dear, we can say it is lossy join. It is lossy join. Now by chase test, my dear, by chase test, how many attributes we have here? 7. 1, 5. Listen, everyone. A, B, C, D, E, F, G, R1 and R2. In R1 we having A, B, C, E, R2, D, E, F, G. Okay. What we do? We fill first A entry in where? A, B, C. A, B, C and E. And here D, E, F and G. D, E, F and G. Very good, bacha. Now we will write the FDs. Here A, B to C, C to D and D tends to F, G. Okay, bachcho. First of all, A, B to C. You can apply. There is a no two value of AB, because here you are getting only one value. What I told, my dear, ki if no two value of X are same, then don't consider that FD. Getting my point? Here no two value of AB are there. So this FD you can't apply. Can we apply C tends to D? No, bacha. Bacho, why? Please try to understand why. It is not a magic. Some places you find ki LHS, if there are two values, fill the RHS. Mazak hai kya? No, my dear. Please follow the property of FD, functional dependency. Don't say LHS, RHS. You know the FD. Whenever roll number 11 repeat, then sham result will be displayed. So don't write, and this method, this point you not find. If you find only half concept other platform, and I'm not telling any time, but I'm telling because most of the student message me on Telegram ki sir this one is given in this, and they send the link also. I say sorry beta, this is the correct, that's all. What I'm telling ki if one value is there, then you can fill the same entries. But if right hand side, left hand side you having two values, but RHS not having any values, then you fill any value but with same thing, like B1, B1. Don't fill A, because roll number 11 Sham is there, then of course roll number 11 Sham will be there. But if here there are two values in which X are same, then what we do? We pick any value, it is directly written in Ulman book. We write any value that is B1, but that is same for all A. All A. Clear, bacha? Don't write in LHS, RHS. Okay. Now, listen, bacho. C to D. Can we write C to D? No, bacho. Why? Because C not having two values. D to EF? No, sir. Because D not having two. Clear, bacha? So, what is the step? Case test stop either if we find all A entries or no updation in the table. Now there is a no updation, we apply each and every FD, not getting all A entry. So what we can say? It's a lossy. It's a lossy. Crystal clear? Bacho, if it is chamka, kindly write down in chat. Write down, my dear. This question you can solve as a homework. First of all, I am taking this question. Please, this is the GATE 2021 2 marks. GATE 2021 2 marks. Please solve this one. Kindly make a heart in chat box. Yeah, give anything, not only crystal clear, bacha. Some data driven line, not a fixed line. Enjoying or not, hashtag. Now, let me know what is the correct answer for this one. How we do, my dear? Here FDs are given. R is given. RST. X, Y, Z, W. Q to X. X. P to YX. Y. And Y to ZW. y2 zw. Decomposition one is mentioned. You can say r1 is what? pqst. pqst. r2 is what? tx. rt is what? tx. r3 is what? qy. r3 is what? qy. And r4 is yzw. yzw, my yzw. I know you done this question, but most of the student not getting. So I will solve you by two approach. I will solve you by two approach. Don't worry, bacha, why you fear? First of all, when you take the union p q s t x q y y z w, you are getting each and everything. R is not there. I written. That is my mistake. Only q s t. Okay. Now listen. R1 is what? PQST, and R2 is what? PTX. What is the common attribute? PT. When you take the closure of PT, you are getting PTYX, blah blah blah. You are getting PTX. Mean to say super key of R2. Super key of R2. So what we can say? R1 to PQSTX intersection R3 QY. Then what is the common, my dear? What is the common? Q. When we take the closure of Q, then what we are getting? QY. That is what? Per key of R3. So what we are getting? R1, 2, 3, QST, Y, EQST, XY, EQST, XY, and R4, YZW. When we take the closure, what is the common attribute? Y. When we take the closure of Y, what we are getting? YZW. So you are getting super key of R4. Per key of R4. So what we can conclude? R1, 2, 3, 4, PQST, PQST, XYZW, and it will be lossless, my dear. It will be lossless. Now same question I will do by chase test. Bacho, can I do by chase test? Can I do by chase test? Everyone let me know fast. Can I do by chase test? How many attribute? PQST. 4 and 8. 8. 8. How many relations? Have R1, R2, R3, R4. PQST, XYZW. We have a R1, R2, R3, and R4. Okay. Now here R1 is what? ST. R2 is what? PX. R3 is what? QY. And R4 is what? YZ. So what we do? Wherever PQST, we will write A S PTX. PTX. PTX, then QY. Then Q and Y might. Then YZW. YZW. YZW, my dear. Now you apply the condition, but you apply the condition. Each and everyone, please apply the condition. Apply the condition. What you do? What you do? Nothing do. Just write each and every FD. PQ determine X. P determine YX. Q determine Y. Y determine ZW. Okay. Now first I am taking FD number 1. Can I able to apply? Can we have to consider FD number 1? Please put your pen down. PQ determine X. Can we have two PQ value same? No. Only we are getting one PQ value same, not getting same. You can't apply. You can't apply this. Can't apply. You can't consider this FD. Can we have P value 2? P2YX. P2YX, my dear. P2YX. So here you can see P. We have a two P values. Now, can we have Y and X? Can we have Y and X? Here we don't have any Y. Can we have any Y value here? Can we have any Y value here? Let me know, please. Yeah, you directly apply first. Q determine Y. Q determine Y. Can we have two Q values? Can we have two Q values? Yes, we have a two Q. What is the A value, Y value? What is the Y value? A. Then you fill A here. This FD we've done. Now Y tends to ZW. Can we have two Y value? Yes. Can we have two Y value? Yes. Then ZW? No. Then we fill any entries. Now check this FD. P determine YX. P determine YX. Can we have two Y value? P determine YX. First I am taking, my dear, you can take in any order. First of all, you can take in any order. Whatever first round you will find, like Q determine Y. You can see Q, we are getting one A. So we fill here A. Okay. So this one I taken first. Now P determine YX. We are getting P value, A values, then YX. Can we have anything? Can we have anything, my dear? P2Y and P2X. You can write this FD according to the decomposition rule. P2Y and P2X. What is happening? P2Y. So we have a one Y value. Yes, you can write here. Can we have one X value? Yes, you can write here. So this FD is. Now Y tends to ZW. Y tends to ZW, my dear. Y tends to ZW. So you can check Y tends to ZW. We have a Y value here. Not only two, more than two are here. But what we are getting here? AA. Mean to say, let us assume this is a roll number 11. Sham, this is a roll number 11. Then what you are getting? All values of A. So my dear, yes, you can fill with complete A here. I am not denying. That is also okay. But my result is getting all A entry, then we can declare. Getting all A entry, then we can declare it is a lossless. Crystal clear, बच्चों? Crystal clear. You can do for 4 relation, 5 relation, 6 relation, and even in the paid classes, I will take also these things for a 7 relation, 6 relation. बच्चों, enjoying. I am telling simply कि बच्चों, whatever FDs you are able to satisfying, you can write, and whatever, like here PQ value, not two PQ are same. Sir, you have this one. Don't say in this form LHS, RHS. You can see here it is also A, na, then we can think about this FD. P tends to Y, P tends to X according to the decomposition rule. Q to Y, Y to ZW. So here Y we are getting 4 Y value same, and what is the ZW? AA. So you can fill here AA also. Here I am getting values with clear. In exam we can use method. It's up to you, bachcho. This method also give the correct answer, and this method also give. Okay, if you want table wala approach, you can use this one. If you want this approach, you can use this one. I prefer generally me. It depend on up to you. You can use this one also. It is also very simple, and it is also very simple. But I can use, I know the properties, attribute closure, blah blah blah, and any combination. But in this you have to more conscious. Any combination of all. So here D1 is lossless. And bacha D2 is loss. D2 is lossy in this. Already you tell the answer. So this one is the correct answer. Okay. Now I am giving one homework question. This one. Please, this is the same question. One and this one. Same data. For a same data, you will solve this question. Okay. This is the chase test. Now again I repeat the chase test. What is my point? First of all, create a matrix, a table in which column represent the attribute, in which column represent the attribute, and tuple represent the subrelation. Then fill the entries in the cell with corresponding attribute of corresponding attribute of corresponding subrelation. I hope so you are getting. then fill the entries using the FDs. How the FDs? If x having two same values, if x having two same values, then there are two possibilities. Either you will get one y value or you will not get any y value. If you not get any y value, you fill B1. And please, now you can solve the Ullman books, exercise, example, each and everything. Okay, there are lots of questions are given in one also. है ना? It's your task, homework, है ना? And you find the soft copy on internet. Don't worry about that. Sir, how we find the exercise book? है ना? Example is also given. So t1 dot x equal to t2 dot x, then t1 dot y, t2 dot y must be same. Means if you are getting two same value of a, then one y, then you can fill y. Because roll number 11, Sham, then anytime roll number 11 repeats, Sham result will be different. But if no two x value are there, then don't consider this FD. If we find all rows with with A entry, then you can say it is lossless. When the change algorithm will stop, either you will find all A entries or no updation. For example, here you can see you are not getting any all A entries or no updation. Like AB to C, you are not applying. It is a repetitive process, you are not checking. C to D, not getting 2C values. D to E, F, G, not getting 2D values. So you check it, there is a no updation in the table. Then you can declare loss. Okay, so we discuss this question also. Now dependency preserving, I think today I will start, but don't worry. First of all, let me know if there is any doubt. Are you enjoying this method? Please let me know fast. You know, what happened? Then know this method with name as matrix method, yeah, and a table method, whatever. But one of my student, na, that ask what is the chase test in DBMS, and believe me, in interview, one of the interview, he shared her experience, na. So she shared me, sir, I forgot what is the chase. I told, beta table wala, or which one, lossless join wala. Please remember the name, chase test. Not asking ki apply the chase test. What is the difference in Vijay dropper batch and other batch? Vijay dropper batch, because student, we assume student already know the theory, so we will explain little bit theory, not user friendly method. No bacha, Sima, chase test is also good. If you solve na, if you solve 5-6 question from Ullman book na, then you can like this method also. Believe me, both are good. You can't comment on anyone ki this method is good. What is in your practice? Both are good, I'm saying. Okay, Manish, in other batch we will take each and every class from the basic also, but in dropper batch little bit less theory, and we will solve more and more questions. And already in YouTube orientation session is there, and already specify the difference between VJ batch and dropper, VJ dropper batch and other batch. Okay, so VJ batch especially for those people that are pass out, yeah, you can say, which already cleared the gate exam, and we assume that they have little bit conceptual knowledge. Then we start not from the zero level. We start we explain the concept, but not start from the zero. Okay, and there are some difference in term of practice questions, DPP or weekly test also. You can watch the complete video. So thank you everyone. Tell me really you are enjoying or not. Write down hashtag enjoy. Write down hashtag enjoy, my dear. Each and everyone. Let me know. Thank you, everyone. Thank you. Thank you. God bless.